to confirm that we have a quorum.
Oops. Yep, we have a quorum.
So I'd like to update the members and public on our new process for both member and public comments. The primary members will be using their cameras and will take live public comments. Members are asked to turn on their cameras when they have a comment or question, and then we can recognize you. And I'm going to ask Kim to go over some basic instructions for both working group members and members of the public to participate in the meeting. Kim?
Okay, I think I read this every one of our Zoom meetings, but I'll just to let you guys know. As noted on the cover page of today's meeting agenda, in addition to emailed comments, the public may also provide live comments during today's meeting. In order to do that, when public comments are called for on an item, click on the raised hand icon on the Zoom control panel on the top right of your screen. You will be called on by the name you registered with, and then you may provide comments. There's no need to mute your microphone. The organizers will unmute you when you are called on. The instructions for providing live comments are also on the bottom of the cover page of today's meeting agenda, which can be accessed from the homepage of SANDAG's website at www.sandag.org. All comments, whether emailed or live, will be made part of today's meeting record.
That sounds amazing. So let's go ahead and get started with item number 2, approval of the June 8th, 2021 meeting minutes. Anybody willing to make a motion?
Trish Smith will make a motion to approve.
Thank you, Trish. Do I have a second?
I can second. This is Susan.
Okay, we have a second from Susan Wynn. Thank you. Do we have any public comments? Kim, I'm not seeing any.
No.
Any member comments?
And members, you don't have to raise your hand. You can just comment.
Okay, seeing none. We will get on with the tedious roll call. Kim?
So it's either yes, no, or abstain. So I'll call your name. Leanne Carmichael, County of San Diego.
Yes.
Kristen Forberger, City of San Diego.
Yes.
Who do we have next? Stephanie Cervantes, City of Oceanside.
Stephanie, you're muted.
Stephanie, I think you're on mute.
Yes.
Roseanne Humphrey, I see you're with us.
Yes.
Okay. Who's next? Cheryl Goddard, City of Chula Vista.
Yes.
Stefan Galvez, Caltrans.
I will be abstaining since I was not here. Thank you.
Let's see. I don't think David Mayer's here, so Hans. I saw your name up here. No? Did we? Oh, thought he was on. Okay, no.
Saw his name pop up. Yeah.
Susan Wynn.
Yes.
Robert Fisher, USGS.
Yes.
Michael Beck, Endangered Habitats League.
Yes, I think I may have missed the last meeting, but it's still appropriate for me to vote yes, I think.
Okay. Trish Smith,
Yes.
Candace Woe, San Diego Foundation,
Yes.
and Jim Whalen.
Yes.
Okay. Thank you, everyone.
Thank you. I assume that motion passes.
Oh, yes.
Okay, we'll move on to item number 3, public and member comments. I will ask members of the public who wish to offer public comment not related to a matter on today's agenda to please raise your hand at this time so we can call on you.
I don't see anybody.
Okay, seeing no raised hands, are there any comments from members on things not on the agenda?
Yes.
And again, you can just unmute and speak. Okay,
Um,
Michael.
Just wanted to confirm, we don't have another EMP until December, is that correct?
That is correct.
Okay. And are we going to be discussing the grant process at this meeting today?
Yes.
It looks like it's embedded in the agenda. Okay, thanks.
Robert?
Yeah, I put 3 recent papers in the comments if people were interested in them. One is, I don't remember if I shared any of these before. Now that we're having these longer times between meetings, is a Golden Eagle one on Golden Eagle movement behavior. One is on, it's from the threats and stressors work we've been doing through. So Golden Eagle is part of the SANDAG work we've been doing. The second paper is on ants, and it's our model of where invasive Argentine ants are in San Diego County, and where the risk is greatest of those ants. And so we're gonna actually at some point put an interactive layer, a model layer on the SDMMP website, so you could look at your landscape and see how it falls in the risk as it relates to invasive ants. And there's big differences between North County and South County and East County in the risk of Argentine ant invasion into reserves. And so if people have questions about that paper, definitely send me an email, or we can talk about it at another meeting, or have John or one of the authors, lead authors, talk about it. The third paper was funded by a LAG grant from the state, and some funding from USGS as well. And it was done in Orange County, but it's relevant to San Diego because it looks at the terrestrial movement of spadefoots in the landscape. And as people know, spadefoot's a pre-listing species and it's not a covered species, I think, in the MSCP. And as such, if it gets listed by the Fish and Wildlife Service, it could potentially stop restoration projects around vernal pools, because they might be considered take. And so what we did was we really looked at the probability of their movement at different distances around these different vernal pools using telemetry in Orange County. And I think that's pretty relevant to how we might approach restoration and other kinds of impacts, spadefoots, in the terrestrial landscape away from the pools. And so it's quite relevant to San Diego. So I put that paper in there as well. Even though that wasn't a SANDAG work, it's quite relevant to the work we're thinking about for the land grants and other grants. So those are the 3 things I dropped them in there. Hopefully you guys can get them. And if anybody has any questions, I can answer questions some other time, I guess, whatever.
Robert, did you say you dropped them in the chat?
In the chat, it says from host to panelists. So it looks like they
I
should
could
have.
download them. It worked fine.
We can also send them out
Okay.
Yeah,
too.
I just figured that would be easiest kind of live as we're here. And I don't remember if I've shared them before. The spadefoot one just came out last month. So that one I know I haven't shared.
I'm just not seeing them. So, but if others are, that's great.
Because
Yeah,
you're
I
not
do.
a panelist, you're the leader. It's host and panelists, so it didn't go to
well.
you.
We can send them out after
Yeah.
the meeting with all the materials.
I have something for member comments.
I think that'd be great.
Courtney,
like
if you
to
could
see
bring
them.
up the slides there.
Kim,
First of all, hello, everyone. I miss us not meeting face to face. I like this platform. It works well for many things, but for meetings, it just doesn't work for me. That said, I think Kim and Courtney have done a wonderful job with these meetings, and it seems so smooth now compared to when we first started 18 months ago. So if it seems like I disappeared for the last 6 months, haven't seen any of you, it's because basically I did. I've been working on the EIR for the regional plan. So you've had presentations at this working group on the San Diego Forward, the 21 regional plan. It's going forward to our board in December. And what I've been working on for the last 6 months is completing a draft EIR. It's probably the most expedited timeline we've ever been on in terms of going from a project description to a draft EIR that I've ever worked on. So if you're interested, you can look at the San Diego Forward EIR. It's on our website, sandiegoforward.com. You can look at the left-hand side, there's an EIR on the pull-down screen or also on the banner itself. What I wanted to share with you today is just one little glimpse of two topics. One is on habitat and the other one is on agriculture. And I think it's very pertinent for the working group to understand how much different the San Diego Forward plan is and why I think a lot of us from an environmental perspective are thinking it's such a much better, does a much better job in our regional plans in the past. And Courtney, if you could advance that. So you may recall that our last regional plan was done in 2015 under a different board, different leadership, different executive director. And in that plan, there was about 108,000 acres of impact between native habitat and agricultural lands. And so it's a significant amount of impact. Most of that was in the backcountry, whereas just complying with the general plans of the jurisdictions and the county's general plan, it absorbed a lot of land out there. Our 21 regional plan is completely different. It focuses on a land use pattern of our sustainable community strategy that is more compact development in things we call mobility hubs. So think of more urban development, more infill development, less urban sprawl. And the upside of that for the environmental community is much, much less impact to native habitat and much less impact for the conversion of agricultural lands. You can see that center idle here talks about the amount of area of upland, wetlands impacts and uplands impacts. Combined, that's about 7,600 acres compared to over 80,000 acres in the last plan. And agricultural lands has a similar pattern where it's 27,000 acres in the previous plan and about 7,600 acres in this plan. So what you get is you get about 93,000 acres of conservation greater under the current plan and the last plan. So roughly it's between 80 to 91% more conservation that we saw. So I just wanted to share that one thing with you and kind of energize you to say, hey, this regional plan is a good thing for what we've all been working for, which is habitat conservation plans. And with that, I'll just turn it back over to the chair. And if you want to ask any questions, feel free to email me or ask me back again sometime. Thank you.
Can we ask you a question right now?
Sure, if the chair permits.
Absolutely, Susan, go ahead.
So Keith, on that last slide, it's not that necessarily that land is being conserved, it's just not being impacted, right?
So yeah, so the last plan would have impacted 93,000 more acres than this current plan. So you're talking about, we looked at the number of housing units. You're roughly talking about the city of Carlsbad in the backcountry, and that's no longer happening. So you're right, Susan, there's still 14,000 acres of impact for future growth, but that's compared to over 100,000 acres in prior plans. And that's not saying those have to be mitigated as well. That's just looking at the impact numbers themselves.
Right. But the conclusion that there's 97,000 acres of conservation, it's just that there's 97,000 acres that are still neutral.
Yeah, 93,000 acres that would not be impacted under one plan compared to another different plan.
Got it. Thank you.
Okay.
Leanne, I have a
Anyone else?
few announcements.
Have any either questions else that has comments or questions for Keith?
A quick question for Keith. This is Michael. So the 2015 was the last time this analysis was done. Is that correct?
That's the last time an EIR was prepared for a regional plan. Correct.
Okay. So you went off the county's general plan from 2011, I assume, for the backcountry. And How is that different this time around? Or is that a long answer that I should talk to you about?
I'll give you the abbreviated version. The 2015 plan looked at whatever the general plans were the county at that time. The current plan is completely, didn't look at the general plan at all in the county. It just said where should growth occur, where makes sense to have growth occur. So there is some conflicts or some differences between the land use patterns in our regional plan compared to the county's general plan, but that's understood and known, and they don't have to be completely in alignment.
Okay, gotcha. Thanks. Good progress. That's amazing.
Oh, Leanne, you're on mute.
Anybody else have any questions or any other comments? And then Kim, we'll get to yours. I don't see any hands raised or.
Me neither.
Okay, what have you got, Kim?
Okay, so I just have some few announcements. I did want to welcome a new member. So as some of you know, Bruce April retired from Caltrans as the Deputy District Director for Environmental in June. And we have here with us today, Stefan Galvez Abadia. Hopefully I said that right. He is the Acting Deputy District Director for Environmental. And I think you just started maybe a month ago or so, but I would like to welcome him to this group. And I don't know if you wanted to say a few words or say hi.
Sure. Thank you, Kim. Yeah, it's been about a month now. It's gone really, really fast, right? Big, steep learning curve. So thank you. Good meeting you all. It certainly is a privilege to be representing District 11 from Caltrans as part of this working group. So I totally understand the importance of our level of participation and contribution of this working group. So I'll do my best to represent the department during my interim period down here. I've been fortunate for many years to work with many of your peers and colleagues at regulatory agencies, MPOs, local agencies, as well as environmental stakeholders, primarily in the San Francisco Bay Area. And I've always had great positive experiences on all the work that we do, primarily with the goal of avoiding and minimizing impacts to resources, and then kind of the follow-up portion, which is so difficult, right? The whole mitigation component. I do bring 32 years of experience from Caltrans, and the last 15 to 20 years working in the environmental field. The last 15 years, I was the environmental manager for the Toll Bridge program in the Bay Area. So basically, I manage the San Francisco-Oakland Bay Bridge program, Dumbarton, the Antioch projects, and then other large projects that we've had in the San Francisco Bay, including Devil's Slide and recently Gleason Beach. And those all have large multi-million-dollar mitigation programs. So I've been put to the ropes on some of these issues. So clearly firm believer that collaboration is critical, particularly on these complex and difficult topics of resource conservation and mitigation. So looking forward to my participation on this team and this group. And again, it's a pleasure to be here representing the department. Thank you.
Thank you.
Absolutely. Welcome to the group. Michael?
Yes. Hi, Stefan. Welcome. You've got some big shoes to fill. Bruce has been integral part of the whole EMP family since before it started, actually. So welcome. And I just want to flag one project that's super important, and that's the 67 improvements. And the NOP seemed to not acknowledge the significance of the wildlife movement backstory for that whole stretch of 67. Just wanted to flag that for future discussion.
Yeah, thank you, Michael. Yes, I'm getting up to speed. I do realize that 67 is an important project, and there's quite a bit of issues. But thanks for pointing that out. I'll sure make I'll make sure that I take note of that and bring it to the team and try to guide that conversation from that perspective for wildlife movement.
Yeah, I think you might want to convene a discussion with the people who've been involved, both at SDMMP, USGS, certainly the service and department. Susan's got all the history and background on this, as does Dave. And, just to get some background and perspective from all the wildlife movement work that's taken place over the last 10 years might be useful.
Yeah, definitely. I'm planning to be there next week, and that was one of the routes that I was going to drive and walk. So thank you. And you're totally right about Bruce. It's a big, tall order to fill his shoes. So I don't attempt to do that. I'll try to do my best to, again, guide the department's discussion in alignment with the discussions that you've been having in this group. Okay, but thank you.
Welcome to the group, Stefan. We're glad to have you.
Right, thank you.
And
Kim,
then,
do you have any other?
yeah, so just quickly, Leanne still sitting in for us as our vice chair. We don't have any real direction yet on a chair, so I just wanted to update the group on that. Likely something in the new year. Our agency's been very focused on the regional plan, as Keith mentioned. And then finally, our grant call for projects. So our 10th cycle, which has been, it has been delayed, but we are moving forward. We are Courtney's headed to the PACs in this Friday to get approval to move forward to the board. We're headed to the board at the end of October, and we hope to release it by November 1st. And so the release is going to look a little different because we're going to be releasing it through the BidNet system. Our grant, what are we calling them? Our grant programs administration is going to be, they put together an informational flyer that we're going to be sending out to all the land managers and this working group and the interested parties that kind of walk you through the process of how to register on BidNet. And then we will be holding a pre-proposal workshop probably mid-November, like the week of the 15th. So yes, we are moving forward, Michael. That's it.
Okay, great. Well, seeing no further comments, we'll move on to item number 4, the ad hoc committee recommendations for the allocation of the fiscal year 2022 funding for regional management and monitoring. Kim and Susan,
Yeah,
go
so
ahead and take it
that's,
away.
I'll kick us off. So back in August, the ad hoc committee met to go through the funding recommendations for the allocation of the $4 million for fiscal year 2022. And I think we need to pull up the attachment, the table, but our chair, Susan Wynn, is here to explain the ad hoc recommendation to the EMP working group, and then we will move forward with a discussion and a vote to move this forward to the Regional Planning Committee and ultimately the board in early November for approval. Susan?
Yeah, great. So just to refamiliarize folks with this table in case it generally looks the same each year, but just as a reminder, so the gray column is a summary of the funding that's been expended to date. The green column is funding that we already allocated, approved in previous years, but haven't spent yet. And then the orange or gold, whatever that looks to you, is our recommendations for the new funding for this year. And then these line up, along the following our strategic goals, so tearing back to our management strategic plan and the work plans that we approved. So for this year, this is the second year of the 2-year work plan that we approved 2 years ago. So there's so just to sort of walk through the some of the highlights. So a couple highlights. So the first line there for rare and endemic plants, you'll notice some significant funding there. A lot of this funding is, similar each year to coordinate the regional rare plant monitoring, but we also had an opportunity to partner with the Navy this year to look at orchid spine flower. And so this species is an add-on to our work plan from before to take advantage of that opportunity to leverage our funds with the military funds. And to look at that species across both the DoD lands and then the lands up off of the military base up by Del Mar. So that's one highlight. The next line is our vertebrate monitoring. So this is continued work on pond turtles and flycatcher, tricolored blackbird. There's some funding for the cactus nursery because we've had some fungal issues. And then also there's some additional increased funding to support some genetic analysis for the cactus red. So that's a project that we've been working on, and this should get us to the finish line on that. And looking at connectivity across the landscape. Ongoing funding for continued rare butterfly monitoring. So Hermes copper is a primary target for that funding. Dun skipper is another one, Laguna Mountain skipper. And then the stressors and threats management. So again, these are ongoing studies that will keep on going. Under the vegetation, probably the biggest ticket item in the vegetation monitoring is we were to the point where we need to update our regional vegetation mapping. And so that's a significant cost to update that veg mapping. And then also in this category, you'll note on line 2.7, the land management grants. So we have the existing 10th cycle funding has already been allocated. And so we're starting to build the bucket for the 11th cycle. But given the timing, we didn't fully load that one. So we'll put some money in this year and some money in next year so that we have a bigger bucket for that. Continued connectivity monitoring, the staffing is the same. And then the last item, administrative and science support. So that's to support the outreach with the metrics and to provide additional regional support where needed, some tech support. And then one specific item is that turns out that we're not quite done monitoring and eradicating the pigs. And so there's Fish and Game has funding right now, but their funding is going to end soon. And there's a need to do some coordinated monitoring across the landscape with camera work, et cetera, that SDSU may provide that oversight. And so that task is included in line 4.7. So that's kind of a quick overview. Many of our working group was on the subcommittee. And so hopefully that, they reviewed that up front, but if anyone has any specific questions, we can have those now and I can direct them if I can't answer them.
Do we have questions from anyone?
Don't see any hands.
Do we want to have a motion on this?
What's the motion you want, Leanne? To recommend approval moving forward?
Yep.
So moved.
Yeah, okay. Thank you, Jim. We have a motion. Do I have a second?
Trish Smith will provide a second.
Thank you, Trish. I have a motion and a second to move forward and approve the ad hoc committee recommendations for the fiscal year 2022 annual funding. Let's call for the vote.
Yay. Okay. Leanne Carmichael, County of San Diego.
Yes.
Kristen Forberger, City of San Diego.
Yes.
Let's see, Roseanne Humphrey, City of Carlsbad. see. Roseanne, are you on?
Yeah.
Okay. Yep. Stephanie Cervantes, City of Oceanside.
Yes.
Cheryl Goodard, City of Chula Vista.
Yes.
Thank you. Let's see. Stefan Galvez, Caltrans.
Yes.
Hans Zinn, Department of Fish and Wildlife, California Department.
Aye, yes.
Susan Nguyen, U.S. Fish and Wildlife Service.
Yes.
Let's see. Robert Fisher, USGS.
Yep.
Michael Beck, Endangered Habitats League. Is that a yes?
Yeah, sorry, yes.
That's okay. Trish Smith.
Yes.
Okay, Candace Woe, San Diego Foundation. Okay, and then Jim Whalen. Yes. Okay. You're on mute, Leanne.
We have a passing motion on that, so we'll go ahead and move on to item number 5. Do we have all our speakers here for?
We are all here.
Yes.
Okay, so from UC Berkeley, we have James and Lynn, Cavell and Felix all here. And they've been working with the SDMMP on the development and implementation of a grazing monitoring plan. And that's to evaluate the effectiveness of grazing as a large-scale management tool, land management tool. The team is here to present what they've done to date and their plans for the next 2 years. I'm not sure who's speaking first, but go ahead and take it away.
I'll ride on that introduction. Thank you very much, Leanne, and thank you all for having us here. We're excited to get to talk with you all. So I'm Felix Ratcliffe. I work for LD Ford Consultants in Rangeland Conservation Science, and I'm the project manager for this research team. And we are preparing a grazing monitoring plan and also a pilot study for looking at grazing as a tool for achieving conservation goals in conserved lands, and also we'll be producing a monitoring plan. So we have a team of about 7 researchers who are a mix of professors from UC Berkeley, some cooperative extension advisors from UC Cooperative Extension, and rangeland management consultants. And so on the meeting today, as Leanne said, we have our 2 PIs, Professor James Rotolomi and Professor Lynn Hunsinger, myself, and then also Kaveh Matamed from UC Berkeley. And we're going to try to give a brief presentation. We're going to try to keep it to 20 minutes here. Including some background on rangeland ecology that's advising our work, a brief summary of a literature review that we've been doing as part of this project, an overview of our conceptual approach to how we're orienting towards this pilot study and towards the monitoring plan, and then a timeline with some next steps. So with that, I am going to pass it to Professor Lynn Hunsinger, but first I need to share my screen for the presentation. So hopefully this will work. Okay, Lynn, I think you can take it from here, and just let me know when you want me to advance slides.
I cannot ever remember to unmute myself, but as Felix said, I'm going to give a talk about it's sort of a background to what we're doing next. And it's on managing California's changing vegetation. And these 2 pictures are taken more than 100 years apart, and yet they look remarkably similar, but they belie the changes that have taken place in California, which are extensive and which what we're doing today. Next. California Native Californians occupied, they think about 300,000 of them were in California at the time of contact. And Native Californians manipulated the vegetation for thousands of years. It was a homeland and a larder. So biodiversity, open woodlands, relatively open canopy forests were managed for. Unfortunately, settlers and the American government criminalized burning of all sorts by miners, farmers, and Native Californians around 1900. Really started fire suppression in earnest next. John Muir saw California as a wilderness, this homeland of Native Californians he interpreted as an untouched, pristine wilderness. And a lot of our management cues for vegetation in California have derived from this kind of attitude that nature, as we found it in California, was perfect and simply a product of nature, not of the interaction of people and nature, and not of the active management of Native Californians. Next. As a result of fire suppression, as we've all heard many times now, we've had a lot of vegetation changing in the forests. We've lost meadows and the trees have thickened and can no longer tolerate droughts. Next. But even more than that, for those of us in Southern California and in the coastal regions, settlers brought in livestock and grasses and cultivation that had been together in the Fertile Crescent for 6,000 years or more. And they were brought to California kind of in a package, first by the Spanish in 1769. And the grasses that came with these crop seeds and with the livestock and with the feed dominate California. They're the non-native annuals that we hear much about. Next. These grasses are tremendously good forage for livestock. They grow a lot of it, and they respond very strongly to rainfall. And they can triple the fire frequency in areas because they are so flammable, such good fine fuels. Next. And they're largely driven by our very irregular and uncontrollable rainfall. So a lot of what happens on the grasslands today is in control, not of us, but of the rain. Next. And in fact, we consider that a major driver of California grasslands. So here's a reef, a healthy reef with a lot of diversity of coral and a full complement of herbivores. Lots of biodiversity in this reef. Skip the next and go to the next slide. And this is what it looks when the herbivores are removed. And most of them are removed. And it's just overgrown by vegetation. And that's kind of how I see California today. Next. So here's a hill near San Jose in a graze condition with a lot of different kinds of plants and flowers. Of course, we like that. And to make it even better, the local residents decided to exclude grazing. Next. And they wound up with a thick thatch of non-native vegetation that suppresses many of the plants and also impacts a lot of the habitat of native species. And this thick thatch, driven by rainfall, driven by these non-native grasses, is having a tremendous impact on California ecosystems. Next. And also on the shrubs, coastal shrublands with the annual grasses going up into them, they tend to burn much more rapidly and too frequently. Next. We have prescribed burning that we're all trying to do. Next. We have cultural burning by Native American people, very active in this sense, very nice. Next, but it's hard to do, sometimes costly, hard to get a permit. You have to be in the right window. You can't always do it during the right season. Cattle grazing, we have 1.7 million hectares burned in 2020 in fires. We have this massive thinning project for 400,000 hectares. We have prescribed burning that we do today. Permitted was about 40,000 last year. And we have targeted goat and sheep grazing, which is of course great. All of these are great. But only about 30,000 hectares a year. We've had trouble scaling up a lot of the management we need to do. But on the other hand, the cattle grazing that goes on even now with our reduced herd removes 5.3 billion kilograms at least of dry fuel from our rangelands and grasslands and shrublands every year. So in fact, next, this turns out to be, this is an example, people actually in California, some agencies are giving out excess vegetation disposal permits instead of grazing permits. But next, it turns out that grazing is one of the biggest vegetation management activities in the state. How to manage it, where to put it, when to put it, these are all things we need to know more about. And that pretty much underlies what we're doing in terms of our project. Thank you, Felix. I think my 5 minutes are up.
Great, thank you, Lynn. And our next speaker is going to be Kaveh Motamed.
Okay, hello everyone. Can you guys hear me?
Yep.
Great. Okay, so my name is Kaveh Motamed. I will be doing the scientific literature review on behalf of the UC Berkeley Range Lab. Next. Okay, so we're going to look at the subject areas we looked at, the type of studies that we gathered, general conclusions, and then the gaps in information that we've identified. Next. So here you'll see that there's 9 main topics that we looked at, and I'm going to briefly go over each one in a minute. But the types of studies we looked at were published, experimental, observational, modeling, review/book chapters, and technical reports. And before I go into these specific topics, I'm going to give very brief general kind of conclusions about each one. And it's just important to note that these are all because of site-specific studies, and that something that works at one site or one area of California may not work in the other one. So our literature review really serves as a great guide to help develop management plans for grazing. Okay, next slide. Okay, so grazing for fire risk reduction. So cattle have been shown to be a very great large scale, or just livestock in general, great large scale management tool to reduce fire risk. Cattle are a great example. They're able to graze large spans of grasslands and reduce those fine fuels, especially these exotic non-native plants that are invading. And then as well as there's goats, they're another example that they can do more targeted grazing of woody vegetation, for example. Next slide. Grazing to enhance disturbed native grassland and foreland habitats. So once again, there's a lot of great literature on this. Cattle are able to, especially in California with a moderate level of grazing, cattle have been shown to really enhance our native grasslands by increasing biodiversity, increasing foreland cover, as well as reducing the exotic annual seed bank. Next slide. Grazing to enhance native coastal sage scrub habitat, specifically focusing on southern coastal sage scrub or Diegan coastal sage scrub. Unlike the other topics I discussed, the relationship between cattle and coastal sage scrub is the direct relationship is not as well studied in published literature. And so we see it more as like a tool to revert or like help the adverse effects that are negatively damaging these coastal sage scrub habitats. So in the case like Lynn mentioned, these more frequent fire frequencies are not allowing coastal sage scrub to necessarily reestablish itself. And so grazing can kind of help reduce the fire intensity and lower those exotic seed banks that are invading into coastal sage scrub habitats. Next slide. Climate and drought. So we just wanted to create a good body of literature on this specific topic to just describe the trends that we're seeing and that, you know, contribute to these problems and how grazing could help. We are seeing a later onset of the raining season, increase in sharpness and peak rain, as well as longer fire seasons. Next slide. Type conversion. So type conversion is in general just when you have one state of vegetation that shifts to another state of vegetation. So as in the pictures show coastal sage scrub to grassland. And this is particularly important for coastal sage scrub because we're seeing these more frequent fire intervals, invasion of exotic annual grasses, more fine fuels because of that, and then these increasing of more fires, less time for coastal sage scrub to really reestablish itself. So once again, kind of connecting itself to grazing and its ability to potentially reduce these fuels that aid in this fire frequency interval. Next slide. Grazing and covered species. So grazing doesn't necessarily have a relationship with all species, but there are some examples of positive relationships, such as burrowing owls or Stevens kangaroo rat. Grazing is able to create these lower biomass situations, lower vegetation height, and allow these species to thrive. Whereas on the opposite end, there's something like the California gnatcatcher that relies heavily on healthy coastal sage scrub stands. And so poorly managed grazing, or if you use the wrong kind of livestock, which I'll touch on in a second, could negatively affect that habitat without the proper management and planning. Next slide. Okay, so monitoring. This is a really important one. Monitoring is essential in understanding if your management practices are actually meeting your goals and objectives. Classic example in rangeland management is RDM, or residual dry matter. And this is the biomass left standing at the beginning of the new growing season. And this is just a good way to monitor how you're using your forage and how much is being used. And then this is not necessarily to be confused with something like if you're managing for burrowing owl, you may have to monitor multiple times a year the vegetation height. And so that's kind of done in addition to something like RDM. Next slide. Benefits and trade-offs of different animals. I've mentioned cattle for grazing grasses and goats for grazing woody vegetation. So depending on the type of livestock you choose, it could have effects on your management goals. So if you're trying to preserve a stand of coastal sage scrub, probably best not to have goats near that because they'll probably go directly to browsing the woody shrubs. Next slide. And then the final one is ecological site descriptions and associated state and transition models. I'll hold off on this as Dr. Bartolome is going to talk a lot more in detail about this particular subject. Next slide. Then finally, just information gaps. As you see, I've circled 3, grazing for fire risk reduction. There is a significant amount of literature on this topic, and it's a very active field, including people on our own team who have their own separate projects relating to this. But there's a lot of uncertainty that goes with modeling in a lot of the published literature. And so that's just something to note and be aware of. Then there's the other 2, which is grazing for coastal sage scrub, as well as covered species. I circled these because there's just not enough published literature on all the specific species or the direct relationship between cattle and coastal sage scrub. And so that's why we have some information gaps there. Next slide. And then, yeah, that's the end of my presentation. Thank you, everyone.
Thanks, Kaveh. Great. So our next speaker will be Dr. James Rotolomi, also from UC Berkeley.
Thank you, and thank you for inviting us. We're happy to talk to this group. I presume you can hear me, and I did unmute myself. And also thank you for Lynn and Kaveh for the introductory material. So what I'm going to do is talk about my titles, Evaluating Grazing Management as a Conservation Tool, but I really want to go into what our underlying model is for developing our goals and objectives for the monitoring. So next. So these are my, I've made my outline fit what our tasks in our agreement. So we have 6 tasks that are in our memorandum of understanding and funded in the project. You've just heard about task 1 and task 2. So task 1 is project management. We're coordinated, we work together. Kaveh's talked about the literature review. And what I'm going to do is talk about tasks 3 and 4. So task 3 is how to design a monitoring plan for multi-species grazing pilot study. And then 4th will be implementing the pilot study. So we'll be talking about those. And tasks 5 and 6 are in the future, and Felix will probably touch on those when he gets into his talk. Next. All right, so just in looking at the models we're using, one of the things that we use is we'll use concepts of multiple scale, both spatially and temporally. And on rangelands, we often look at ecological sites. These are in tens of thousands of acres. They're areas with similar vegetation and similar drivers. And looking at drivers, which are the factors that influence the composition and function of these types, geology and soils and climate change are major drivers to look for on ecological site. This helps us guide how we're going to do our monitoring. We also look at the ranch scale. That's got, could be in thousands of acres. There we still have soils and geology, but then you bring in the drivers of economics, weather, and land conversion. And then finally the pasture, which is one of the management units for rangelands, hundreds of acres. We still have soils, but then we can include fire, grazing practices, invasive species, and residual dry matter. So this is one way of organizing the information. It's not considered not to be exhaustive, but it's illustrative. So next. So one example, we've already heard about burrowing owls. So this is a pasture at Rancho Hamul. And in this case, we have an area of rangeland. It's got low levels of RDM. Those are burrowing owl shelters. There's been grazing management to work on improving burrowing owl habitat. It's been very successful. This is the kind of landscape that we're looking at and trying to look at, what are the drivers of this kind of landscape and how do we manage them to favor our targeted goals, in this case, burrowing owl habitat. That's one example. Next. So in looking at these areas, and we're focusing on what's called the ecological site. These are areas they can be at different scales and different temporal scales. Ecological sites have an official government terminology that the NRCS has adopted. we think of ecological sites in a broader sense. Our ecological site descriptions, the ones we've done in places like conservation areas of Tejon Ranch and other places, is one that builds on the NRCS approach, but we don't use exactly the same concepts or approach as the NRCS. The NRCS allows for 3 different kinds of categories of ecological sites. There are approved ones, which are officially documented, approved, and recorded. There are provisional ones, which are not completely approved and need more work on them. And then there's a third category where you can produce ecological sites that are similar to the official ecological sites, but have a different kind of background and different sorts of goals. We are in that third category. However, what it does require is to gather information at location. So this is helping to develop an ecological site description for conserved lands on the Tejon Ranch. So in this case, we have a crew that's out sampling spring vegetation. This site is called the Sandy Alluvial Flat Ecological Site, which covers a range of locations. They don't have to be contiguous locations, but they're the main focus for doing monitoring. Next. So in this case, we've developed ecological sites on the Tejon Ranch, and this illustrates how that might fit into the landscape. So here are a whole series of ecological sites along a transect that goes from the San Joaquin Valley up to higher elevations in the Tehachapi's. The photo I showed you was of the Sandy Alluvial Flats, but then they come into Pleistocene terraced remnants, loamy sands, sandy clay loams, and so forth. So this is a way of organizing information so that we can focus our monitoring on identifying the drivers and testing hypotheses about why these ecological sites may or may not be stable and may or may not be influenced by management. Next. Once we have these sites defined, an integral part of them is to use a state and transition model to develop hypotheses about what kinds of variability you might find in an ecological site. And this is a simplified diagram that illustrates states, which are distinctive subcomponents of ecological sites. And then the arrows with the dotted lines and solid lines represent observed transitions that we saw over a series of years on this sandy alluvial flat site. It doesn't represent all of the transitions that are possible, but these are the ones that were actually observed and could be quantified. Next. So once we have our ecological sites defined and we have states and transitions data-driven available, we can then catalog the transition. I don't expect you to read these, but these are explanations for all of these transitions, and they include what are basically hypotheses about what the drivers are and how susceptible these kinds of transitions are to control and manage. Next. So in this case, what we've got is for this our study areas. The current study areas are Rancho Hamul and the adjacent Holman-Beck Canyon. We're looking next at implementing a pilot study on those locations. So next. This is task 4. This is just an aerial shot of basically the Hamul Ranch headquarters. It shows Hamul Creek with riparian vegetation, some adjacent pastures. In the background is the edge of Holman-Beck Canyon on the far side of the highway. And this is just to illustrate that on this site, we have a lot of diversity of vegetation. There are different kinds of soil types, different land history, different vegetation units. And there are a number of ecological sites here that need to be defined and looked at and monitored. Next. So one thing that already was hinted at by Kaveh is that we have to remember that we're in a Mediterranean type environment where we have rain possible in the winter and then typically not possible during the summer, which leads to a distinctive pattern of growth in both herbaceous plants and associated shrubs. And that this is being such a distinctive vegetation, this results in some big differences in terms of seasonal fuel loads, fire hazard, differences in grazing use, and especially for things like fuels management and fire hazard, a lot of the information on grazing comes from the Midwest, where they don't have the same kind of pattern of plant growth and a long period of dry vegetation that increases the susceptibility of vegetation. So what we're starting off with, and that'll be next month, is we're going to start with measuring residual dry matter, which is in this case, it's the dotted line, the dead material that was produced the previous year. So we'll be looking at residual dry matter and looking at locations that'll be suitable for establishing our first sample plots. Next. So this is an example. This is one of the temporary grazed pastures at Rancho Hamul. It's got electric fence on it. It's been grazed. This actually shows several different kinds of vegetation. There's some clumps of Stipopulchra, native grasses in there. This has been grazed. There's some Baccharis shrubs right there in the foreground, and then some more in the background. This represents the kind of variability that we're going to need to incorporate into our sampling and monitoring schemes. And you could argue that this patch of perennial grasses that are present may be an example of something that is a separate ecological site, or it may not be. It's more likely to be a state that has transition elements. That's part of what we're going to be focusing on in the monitoring scheme. Next. This is just a list of references which you should be able to see when these talks are published. These are some references that refer to development of ecological site descriptions and associated monitoring. So I'll turn this over to Felix.
Thank you, Jamie. And thank you all. I think that we're kind of nearing, maybe we've gotten up to our 20-minute limit here. Kim and Leanne, is it okay if I can just try to do a brief wrap up here?
I think you're good. You're
Okay.
good.
Yes, go ahead.
Excellent, thank you. So I'm just going to briefly try to talk about or briefly describe our preliminary monitoring plan. Jamie already mentioned some of it, and then some of our next steps for this fall and beyond. So Professor Bartolome just laid out the value of understanding some of these ecological site relationships and how some of these things like soils, topography and geomorphology can bound the range of potential vegetation dynamics that we might see at different portions of the landscape. And we have to remember in this study, our ultimate goal is to understand the role of and also the potential for using grazing to enhance the conservation outcomes and various other outcomes like managing rangeland fuels on conserved lands. So how do we go from these kind of theoretical models, this theoretical construct like these empty boxes and arrows in a sort of theoretical state and transition model, to something where we actually have ecological site models for a given landscape with an accompanying state and transition model that describes changes in vegetation over time and the opportunities and potential hazards even of grazing sort of vis-a-vis conservation outcomes on the landscape. And so I'll just lay out like a 5-step process that we're following, I suppose. And the first step is that we need to have specific management goals, right? Or in this case, you could say study goals, right, for our pilot study. And so we're very lucky because these were really very clearly laid out in the statement of work for this project. And we've worked with them a little bit to make this list that you see here. But basically, they boil down to these major goals. Number 1 is to enhance and conserve native grassland and foreland habitats. Goal number 2 is to enhance disturbed coastal sage scrub habitat. Goal number 3, reduce the risk of wildfire damage to the SDMMP lands and to adjacent areas. And goal number 4, maintain the overall health of grassland and coastal sage scrub ecosystems. All of these goals over here on the right have more specific objectives that get sort of to the finer scale objectives that we'd like to see realized as well. All right, so step 1 is goals. Step 2 is we need to have study locations. As Jamie Bartolome just mentioned, We have our two initial study locations, which are going to be Rancho Jamul Ecological Reserve and Hollenbeck Canyon, the adjacent site. These two sites are ideal for our studies because they both have livestock grazing present. They both have grassland and coastal sage scrub habitat on them. We're starting here. It's possible as the study goes on that we're going to add more sites as well. So that will be assessed over time. All right, the third stage of this is that we need to have some idea of what the site conditions are on the ground and what the ecological relationships are between site factors like soils, topography, geomorphology, and the vegetation dynamics in both the grassland and the coastal sage scrub systems on these two study sites. So thanks to a lot of good work through the SDMMP and other local ecologists, there is a good amount of information on this topic. But also, as Kaveh pointed out, there are some information gaps where we need to get a little bit more data. And this is going to be the focus of our initial monitoring efforts. So this fall, we're going to visit Rancho Jamul and Hollenbeck Canyon. Actually, probably in about a month, we're going to get out there to look more closely at how some of these ecological site variables and the vegetation patterns on the landscape actually co-vary together. So to do this, we're going to sample soils and other ecological site variables. We'll measure residual dry matter, as Professor Rotolomi mentioned. We're also going to sample soil phytoliths, which are these microscopic bodies of silica that are deposited in the soils. They're actually biogenic silica created in the tissues of plants, largely grasses, and they can tell us a lot about historic vegetation states, in particular, if some perennial grass species were ever dominant on these sites, which would be useful for thinking about long-term change and potential of the sites. And we're going to take all of this information and make our preliminary ecological site descriptions that we're going to use to guide the next steps of the study. One of those next steps of the study, the fourth step in this sort of 5-step scheme, is to get much more detailed information about vegetation associated with all the ecological sites that we define out in the field. And this will start next spring when we're going to get out and do more fine-scale vegetation monitoring. After that, after we have our preliminary ecological site descriptions and also some preliminary information about what the vegetation states are on these different ecological sites, then we're going to start looking at where we can add grazing treatments to see how grazing affects vegetation on these different sites, affects all of our study goals, affects the MSP species, affects grassland species composition, shrubland composition and structure, and also wildfire fuels. So that's the 5th step, is getting those grazing treatments in and then continuing to monitor to see what happens over time. So just very briefly on timeline and next steps here, this is a table showing in gray, it shows all the tasks that we've completed, including being more or less, most of the way through the literature review. We've still got to produce the final deliverable of the report on that literature review of the synthesis. We're developing the monitoring plan right now. We've got our conceptual model and goals and objectives and a study design underway. But right now we're gearing up for the actual field monitoring. So that's what we're actively engaged in right now. And then we've got these ongoing tasks, which will be, once we get data from our field work, we'll be engaged in data management throughout the rest of this project. And then a lot of different meetings with different groups to continue conversations and communication, such as this one. So thank you all very much. I'm sorry that we went a little bit over here, but we really appreciate the opportunity to get to talk to you all about this. I don't know.
Thank
Kim
you.
and
That's a
Leanne,
lot
if
of relevant information, especially with the wildfire. Okay, do we have any comments from the public or questions for our presenters here?
I have one.
I
Or
don't see,
members?
yeah, I don't see any public hands raised, so.
Yeah,
I have
Jim.
one, Leanne.
Go.
Ready?
Yes.
Ready.
I just saw a statistic that said in pre-settlement days, about 4 million acres burned a year in California. That's a lot of burning. And if that's what it takes to get us back to the safety that we had back then, how does that work with today's world and constraints? Can you imagine burning 4 million acres a year? Well, maybe we are going to imagine burning 4 million acres a year.
I think that's what we did last year, accidentally, right?
I don't think it went that high, but I get your point.
Yeah, Lynn, did you want to respond to that?
Yeah, so I think that's a really good point, and I was trying to say, you know, in that 5 minutes, a little bit about that the world has changed from those pre-contact days, and we probably can't tolerate that level of burning now. And it's, you know, both the smoke and the air quality and the climate change has made everything much drier and more flammable, and probably will continue to do so. I think prescribed burning is really important. Starting from where we are now is really hard. Native Californians had the benefit of having burned year after year, and by the time you've done that, your landscape is not so dangerous and not so flammable, but that took hundreds of years, you know. So I think that's why I would think we need to use every tool we have available. And burning is one, but as a friend of mine, Scott Stevens, who's quite a good prescribed burner, says we're not going to burn our way out of our current situation. It's just not feasible. So we need to use all the tools we have, and that includes cattle, that includes goats, that includes hand clearing, that includes thinning, that includes a lot of things that we can do. We also have people's houses all mixed in with the vegetation now, so things have to be done differently. We can't sort of go turn back the clock, but we can certainly learn a lot from past practices. We can learn a lot, and we should respect and learn from that knowledge. But we have to consider that everything's changed.
Yeah. Hey, Robert, what have you got?
Yeah, thanks. When you guys come down here, maybe we can do a field trip, because I guess one question I have is you'll be able to tell from your paleo soil analysis that whether what we are calling rangeland or grassland now at Rancho Hollenbeck is actually should be scrubland or was historically scrubland, right? Because I think that's going to be an important outcome to know whether we want to continue grazing or if we want to shift it in a different way to a different land cover. And because there's areas that are similar to that are scrubland now that haven't been agged and overgrazed, and that might be a good paired comparison to some of those sites. And so I guess my question is, you can be able to tell from that paleo assessment that this was scrubland or chaparral or riparian habitat, steep habitat versus foreland, right?
Great question. Bartolome, I don't know if you want to answer that. I would be happy to if you don't want to, but you might want to.
No, I'll answer it. That's a good question, and that's one of the reasons we want to try the phytolith analysis. Is it's if it works, it's really good. The difficulty we have is we're going to have to test this out because it is biogenic silica. People hear a lot about the carbon cycle, but there also is an organic silicon cycle that is much less studied that produces these phytoliths. And so they can be preserved for millions of years under the right conditions, but we need to find out what happens in these soils that are in the area we're working in terms of specifics of it to see what we can get. So this really is a pilot study. It has a huge payoff if it works, but it may not work for all sites, and it hasn't been tried in this region on these soils yet.
Yeah, and one thing I'll add to that about the phytolith analysis is it's particularly good at picking up a signal of grasses in, you know, prehistorically and historically, and you can to some degree pick out different species of grasses. For example, you know, Stipropulchra, purple needlegrass, has an identifiable phytolith signature, whereas not all grasses do. So it can give us some information, but it's not it's not sort of like a wide-ranging tool that can tell us about a whole huge host of species, although there is some ability to tell species level, but it could at the very least give us pretty good idea about historic and prehistoric grass, in particular grass abundance at these sites.
And stipa we have in scrubland as well, right? So if you can pick up scrubland elements using this analysis, or only grassland elements using this analysis?
Well, potentially it would tell us, largely it would tell us about grassland elements from the standpoint of grassland species. But you're right that, I mean, if stipa is growing in amongst shrubs, then potentially it would leave a signature, right, in the soil. The question is whether it's, was it a stipa dominated grassland like that photograph that Jamie showed, where it was just a patch of stipa? That's going to have a much higher, level of these silicaceous bodies in the soil compared to a shrubland with a couple stipa, plants in it. If that makes sense.
Great. Well, no, I'm looking forward to that. That's interesting.
Great.
Okay,
Leanne, we have a
Christina?
couple of, after Chris, we have a couple of public comments or questions.
Well, we have, yeah. Christina Schaefer asked, she was wondering why conservation and management for burrowing owl was not included in one of the pilot study.
Great question. So the pilot study objectives, I sort of read out those major goals. The objectives associated with those goals do include looking at how grazing can be used as a tool for conservation benefit for MSP species. And so in that sense, burrowing owl would be one of the species that we're interested in looking at. We are not planning to do direct assessment of populations of MSP species, but we are interested in habitat assessment. So burrowing owl is a good example of one where we know that there are specific habitat variables, like structural vegetation variables in particular, that relate to habitat quality for burrowing owl. So we'll include those kinds of metrics in our study, even though we're not doing direct assessment of populations of burrowing owls. And that will be true for a number of MSP species, that we work habitat relationships into the study rather than direct assessment of populations. So we do want to include these sensitive species, that we think are going to be affected by grazing or potentially benefited by grazing. Even though they are not sort of the primary goals, they're associated objectives, if that makes sense.
Okay.
Can I add something to that?
Oh,
yeah. Just to follow up on what Felix said. The focus of the study really is to look at the efficacy of grazing as a conservation tool. That's our central focus. And in terms of all the individual species and so forth, we're going to build on the really great work that's been done over the last couple of decades on these multi-species conservation projects. And so we're not intent on duplicating that. We're intent on building on that and being able to incorporate it in what we can do. So burrowing owl is a good example. Hamul has been a really successful site for burrowing owl conservation, and we know that. And so it'll be included as one of our sites, but our emphasis is not on repeating or even or impinging on all the really great work that forms the foundation for the work that has been Sandag sponsored over the years.
Okay, thanks, James. Chris Preston, you had your hand up.
Yeah, I just wanted to emphasize in response to a little bit about what Robert was saying, probably our most important goal is to look at how we can use grazing to reduce the impacts of invasive non-native Mediterranean grasses on coastal sage grub and native forelands and grasslands. Fire is important in that we specifically want to look at how we can reduce fire coming up from like Otay Lakes Road and reburning the preserve, because we know that at Rancho Hamul, too much of it has burned too many times and led to this conversion in areas. And then of course you have the historic cultivation. So it's a very complex what we're trying to do across a landscape that has a lot of different drivers and different histories and so on. And what we're just trying to do is see if we can get grazing to restore some of the ecological health in lands that have been degraded by either too much fire or invasion of grasses, and then to reduce fire to preserve these lands.
So Leanne, I can allow, there's 2 questions under the attendees. So I think we have time for 2 more. So I think Alyssa Cope, I'm going to allow you to ask your question. Hopefully this works.
Thank you very much. Love the work that you're doing. Couple questions. Soil health, are you going to be doing any soil sampling pre and post grazing? We think that sometimes the grazing can change some of the soil components. For instance, we do a lot with black mustard, which is allelopathic, and removing that can often change soils and making them more receptive to hosting native grasses. And then my other question is, can you guys include goats? Because they graze very differently.
Great. Both really good questions. Thank you. I'll take a stab, and then if other members of my team want to jump in as well, that'd be great. But we are not planning on assessing soil health from the standpoint of, say, like carbon sequestration or things like that in response to grazing. We are going to be analyzing soils for different chemical and textural properties, and how that relates, and see how that relates to these ecological sites and potential vegetation states that we see there. There is, but I want to say that there is the RCD, the San Diego County RCD, does have a soil health ongoing study at Rancho Hamul. So this is something that we're talking with folks like Tracy Nelson at Rancho Hamul, and we are interested in seeing what happens with this grazing study and how it might affect those results. I think that there's the opportunity for some collaboration there or overlap in studies, but it's not a direct goal of our studies, although it's certainly an area of a lot of research interest at the moment. And the other thing that I just wanted to respond to was your question about goats. We are also not directly, we're not going to be using goats in this study for a couple reasons. Number one, because as Chris Preston said, one of the major goals of this study, really, if we sort of think about it from like I guess, ecological processes, standpoint, we're trying to remove a bunch of non-native annual grasses that are potentially leading to increased fire frequency and ultimate sort of degradation of these shrubland communities. And cattle are a livestock animal that does prefer eating herbaceous forage, in particular grasses. And so they're pretty well suited to some of the major goals of this pilot study, whereas goats do tend to browse more on woody browse, and therefore, may not be the best suited for this. Also, in addition to that, there's already an active cattle grazing program at both Rancho Hamul and Hollenbeck Canyon. So we intend to work with what's there. But great questions. And I don't mean to, certainly don't want to undersell either of those things, because they're both really important topics. And goat grazing in particular for targeted purposes and fuel removals is a really, it's a growing field and an important one.
I think we have just one more question, Leanne, from Linda Ivanov. I think you can.
I'm also with the SAGE Environmental Group. Alyssa just spoke and asked the question about the goats. And we have found with our herd that they're very attracted to the grasses, and their favorite is the mustards. So they tend to avoid the native plants and go for the invasives, especially the grasses. So we would love to see more emphasis or participation as opposed to leaving it with that the goats are more interested in the woody plants. We do find they avoid the sage, and we do supervise closely and make observations. We are primarily habitat restoration and biological resources firm. We've started implementing goat grazing and are tracking, and we've also worked with some conservancies to do growing versus grazing versus mowing and some studies, and we have some data that we've presented to a number of conferences So we'd like you to keep an open mind on the goats at some point, and we'd be interested in collaborating. We're also sharing your data, learning more about your program, and sharing what we've learned. So appreciate that you're doing these studies. It's wonderful.
Thank you, Linda, and thanks for that information. I mean, I think that's a really good point. I will say, just logistically, I think we are not in a position to use other species other than what's currently being grazed there. But I take your point that having an open mind going forward is a really good idea, and there is the possibility for expansion in the future. So definitely we will try to keep an open mind there and think about where opportunities present themselves, because certainly there are some logistical advantages to goats in certain situations as well. Absolutely. So thank you.
Okay, great. Well, that was really good information. I'm talking over someone. Did someone have some?
I'm just sputtering around here and saying that I do appreciate the comment about goats and the history of goat rearing in this group. So we do like goats.
Okay. Well, Felix and Lynn, Kaveh and James, thank you so much for that information. We look forward to hearing more about this study as it goes into the pilot program phase. Hopefully we can hear some more about that in the future and how that turns out. Thank you so much.
Sounds great. Thank you all.
Okay, next up we have item number 6. Jeff Tracy from USGS will talk about developing artificial intelligence, AI software that scans through thousands of camera monitoring photos and selects those with wildlife and can identify to a species level. The intent is to develop camera monitoring and individual recognition software as important components of a long-term mountain lion population monitoring program. Go ahead, Jeff, take it away.
Okay, let's see. Share. All right, can everyone see my screen?
Yes.
Okay. All right, so my name's Jeff Tracy. I'm a researcher with the U.S. Geological Survey. Up until about 7 months ago, I worked in Robert Fisher's lab. So some of you already know that and know me. And then I recently moved into this group within USGS core science systems called Advanced Research Computing. But since that move, I've continued working with Robert and also Cheryl Brummy, who's been involved in this monitoring camera trap project. So I'm going to talk a little bit about that project and what I've been doing since I left Robert's lab. So just as a bit of motivation, last 10, 20 years, there's been staggering advancements in robotics and supercomputing and artificial intelligence, and to the point where people are saying we're in the fourth industrial revolution that revolves around AI and robotics. And so you might ask, what does this have to do with wildlife management? Well, could be potentially quite a lot. It could have potentially revolutionize our ways we collect and analyze data. So I'm going to talk about this camera trap study that we did back in 2012, 2013, focusing on underpasses and animal movement through underpasses. I'll give you a little bit of a background on artificial intelligence and machine learning, and more specifically, a type of machine learning called deep learning, and then talk about the two and kind of putting the two together. So it's by its nature a bit of a, it's a bit of a technical area, and I'll just try to explain it simply. There's no test at the end, so just relax and enjoy it. All right, so the camera trap study I mentioned, we collected data over 2 summer periods in 2012 and 2014, and we had these questions about how small animals were using the larger underpasses that facilitate movement of larger wildlife species under roads. And so we also wondered if we could put some sort of structures inside the underpasses that might help small animals find refuge in them as they move through, and potentially increase their use of those underpass structures. And so we went around the county, found 8 underpasses that had no flowing water moving through them, were fairly large in nature, had native vegetation on either side, went under roads. And those became our study sites. And we placed at each site up to 4 cameras, one on the outside. Let me change over to my laser pointer. So we put one camera on a randomly selected side of the underpass. We put a camera facing inward on each side on opposite sides of the underpass at each end, facing toward the center. And then some of the underpasses, if you can see here, there's like a little concrete ledge. Some underpasses by their design had that kind of a structure. And so we thought it might, facilitate movement of some small animal species. So we put a camera there if on one side, again, a randomly selected slide, if the underpass had such a lens. We use these very nice Reconyx PC800 hyperfire cameras, and the manufacturer changed the focus distance and sensitivity of the cameras for them to make a better use, better able to detect small animal species. And we collected motion detection images and then also time-lapse images at 5-minute intervals. So we collected photos over the summer, April through September 2012, in all 8 underpasses. And then over the winter of 2012, we built these little structures out of piles of cinder blocks and PVC pipe and put them in 4 randomly selected underpasses. And then we went back and monitored with the cameras from March through September of 2013. So it was basically a before-after control impact study design. So you can see some of the structures here, and you can see a snake moving through here. We got all kinds of photos, all kinds of species, lizards, snakes, squirrels, rabbits, all kinds of small mammals. And we also got a lot of use by larger animals. Well, we have a black-tailed weasel, coyotes, bobcats, 2 species of skunks, deer, so on. So we wound up with a lot of photos. And so I wrote a program in Java to help kind of go through the photos and kind of label them quickly. It worked fairly well. We put some of the USGS staff on it, but we also got some help from the San Diego tracking team. So they had quite a few of their members kind of step up and use this program to label the images. And after, a period of time, we had some sense of what was in the data set. This shows the distribution by some species / taxonomic groups of the number of photos in each kind of category. So lots of photos of squirrels, lots of photos of small mammals, but we got, plenty of bobcats. I think we got bobcats in 7 out of the 8 of the underpasses. So the problem is though, we collected over 3 million images, and after hundreds and hundreds of hours of mostly volunteer labor, but also USGS staff labor, we were only able to manually classify about 5% of those photos, leaving over 3 million unclassified and basically unused data that's available to us. So, what are we supposed to do with this? And that's the problem, and that's where artificial intelligence may help us out. So we have over 3 million of these photos that need to be identified, but we also have 150,000 photos that are labeled. So we have this great training data set. And so this is just a scheme showing how we might divide up the data to train a model to recognize what kinds of species or taxonomic groups are in the photos. So for example, we might take, this is actually what we're doing in our current test. We have one site which we call Valley Center Middle. So it's an underpass, one of the 3 underpasses we have from Valley Center. And we're going to leave those aside as a test site. And then we take of the remaining photos that have been classified, 70% of those and used for training, and another 30% to use for validation to kind of evaluate how well the model as it's being trained is performing. So I'll give you a little background on artificial intelligence. So AI has been defined as any technique that enables computers to mimic human behavior. And there's several subfields within artificial intelligence. So natural language processing. So when you speak on the phone, something there's recognizing what you're saying. Computer vision. So it's like understanding what's inside the content is inside of images or video. Machine learning, which is learning patterns from data. And then there's a branch called deep learning, which is fairly new. And so I'll talk about that a little more soon. So we can't talk about deep learning without talking about neural networks. So just kind of get the big takeaway here, but early on when people started making computers, they started thinking about the human brain, and our brains are composed of millions of neurons, billions, and they're all connected together. So they made mathematical models that tried to mimic the behavior of a neuron and connect those together to form mathematical models. And this was done as early as the 50s. And the models were fairly simple, but the people believed they had a lot of promise. And then the development of neural networks kind of took off, and then they found limitations, and then they found ways around those limitations, and it took off again. But now, here we are in the 2000s, and we have really sophisticated computers, awesome hardware, and the ability to process large amounts of data with very large models. And so recently, people started experimenting with larger and larger neural networks and started to learn they had like huge capabilities that we didn't fully understand before. So now it's kind of becoming a predominant approach to doing machine learning. But basically, deep learning refers to deep neural nets, and deep neural nets are just very large neural networks that have often specialized nodes and layers, and they allow us to extract data or extract information from data. There's a type of deep neural network called a convolutional neural network. And these have been designed specifically to process imagery and video. And so basically it's where machine learning meets computer vision. And so here's an example from, there's a reference here on a paper using camera traps in conjunction with citizen scientists who labeled the photos, and using convolutional neural networks to identify species in photos. So this is what I'm doing, what I'm going to talk about. I won't go into detail on how these things work, but it's pretty remarkable. So these kinds of neural networks have been around for a decade and a half maybe, but they weren't very good at first. And then so there's this competition that's conducted every year. So there's this data set called ImageNet, and so they have this large scale visual recognition challenge. So all these computer science groups kind of compete and try to see who can outdo each other. And in 2015, they finally developed, it was Microsoft developed a neural network that exceeded human level performance on this data set. So that was kind of considered kind of like a turning point in the use of this technology to identify the content and imagery. And this is only 6 years old, this technology. So it's been made more and more possible by advances in hardware, for example, GPU computing, and software tools to allow people to build these models much more easily than they could be built in the past. And I work at USGS, and so we, as an organization, have invested some money in developing resources for this. So we have supercomputers in the group I work in, and one of them is called Tallgrass, and that machine is specifically designed to do machine learning and deep learning work. So basically, the whole process is, like any sort of data analysis, you have to get the data together. You have to get it together in a pretty specific way to be fed into these models, because you're dealing with gigabytes upon gigabytes of data being passed through models over and over again as the model's being trained. So you have to set up this pipeline that feeds the model, the data into the models quickly. And then once the models are trained, then you evaluate their performance. So it's a lot of coding, a lot of experimentation. To get these things running and working and performing well. So the model I started experimenting with is called ResNet 50. There's more detail here than you probably want to understand. This diagram on the left is sort of a simplified diagram of all the layers in this model. The point is, it's a huge model with over 23 million model parameters that can be trained. So clearly some pretty sophisticated algorithms are required to do this, and a lot of experimentation and tuning of those algorithms. So we started doing some simple tests by classifying 3 species or 3 two species, and then photos that have no animals in them. So we have this none category deer, and then the BOBC is bobcat. And you can kind of see some of the photos are pretty poor quality. Granted, these are small, but I can't see a bobcat in here. It's hard to see a deer in here. You know, sometimes they're far away. Sometimes we just get the legs of the animals. So, you know, it's kind of a tough challenge, but with this simplified data set with just 3 species, you know, I was trained the model, it performed pretty admirably, got over 95% accuracy, actually over 96 for deer. And so that was pretty encouraging. So recently I kind of stepped it up to, I'll skip this slide, stepped it up to trying it on 20 different classes. So, you know, it could identify images with birds? Can it identify images with dogs? Can it identify, you know, granted there are, you know, a coyote and a fox category, which is similar to dog. So we have some categories here that are sort of similar, you know, wood rat, you know, mouse, rat, K-rat, all kind of similar. So kind of a challenging problem. In my initial tests, I got, you know, 86 or 88.5% accuracy. That's not bad. I want it to be up in the 90s. So I have some work to do to get it to that point, but promising. So basically the main point is, you know, we're going to be able to turn camera traps into basically wildlife sensors. There's this other idea called edge computing, where you actually put the AI software and computational hardware on the device itself, and can, as the images are being fed in, they can be processed in real time and data generated right in the field on the device. So that's something that will be coming in the future. So another project we're working on is individual recognition in the images. And so this is going to be a more challenging problem. And, you know, we're not entirely sure how it'll work, but we'll find out. It's been done with some other species, for example, chimpanzees. It's been done with cattle, various other things. But our goal here is to try to identify mountain lions individually in images. And so it's kind of a multi-step process. You know, first we have to identify what part of the image, either the whole body of the mountain lion is or its head, extract that part of the image, and then feed it into the approach I'm going to experiment with is called a Siamese neural network, basically because it has these two backbones that are parallel with the same weights, and you pass two different images into them, and then it produces output that basically is what's the probability that these images come from the same individual. So that's the approach we're going to try. In the end, you wind up getting this giant matrix of, you know, pairwise comparisons between photos. And so then you'd have to do at the end some sort of clustering to group them together by hopefully what would turn out to be individual animals. Of course, like any statistical analysis, there's going to be some probability of uncertainty with this. So yeah, so in summary, you know, I talked about a little bit about artificial intelligence, machine learning, and specifically deep learning for computer vision. Talked about our camera trap study that we're using as a data set to work out this process. Some of the experiments I've done, and a future application of this technology to identify mountain lions in photos. So that's what I have for you. Any questions?
Do we have any questions for Jeff? Here I was feeling good just installing a new router at my house. And
It's, yeah, don't feel
okay.
bad.
Yeah, that's no. I mean, that's incredible work. I
put this, well, I put this photo of the red diamond rattlesnake here because I miss those days of being out in the field and just looking at snakes, you know. So anyway, sorry.
Well, I hope that day doesn't come that we don't get out in the field to actually, you know, interact and witness these things ourselves. But does anybody have any? I see Chris's hand up.
Yeah, and there's
if anybody else has any questions, please get your hands up. Or
there's one from Megan Jennings. So I don't know if you want to take Chris first or Megan.
Okay.
Let me know.
Go ahead, Chris, and then Megan's next.
Okay, I just wanted to say Jeff's doing some amazing work, and our goal with this work is going to form, if we can get the individual recognition, it's going to inform our monitoring program for mountain lions, or it has the potential. So Winston Vickers from UC Davis is working with Jeff on this. He's sending them lots of images of mountain lions to classify. And the idea is that we would do, right now, Winston, over the next couple of years, is going to be working with experts to develop the mountain lion monitoring plan. And the idea is to use a combination of genetics and camera monitoring to estimate the number of individuals in our population and make sure that they're not getting inbred, which is the real concern. So I just wanted to say that the work that Jeff has done with the underpass study to identify the species has been a really important building block, and it looks like he's improving that. And then once we get that, we're going to really try to do this individual recognition so that we know how many mountain lions we have in the Eastern Peninsula Range and can monitor them over time. Because as you know, the state is proposing listing our population as endangered, and it's a real concern because of the loss of connectivity. So I just wanted to make that point.
Yeah, thanks for saying that too, Chris, because I emphasized here the species identification. The photos part of the work I'm doing, but yeah, Winston is really leading the way in the individual puma recognition part of the project, and I've been working with him quite a bit in the last couple months to kind of develop the kind of concept for how we're going to do that and get some of the data together that we're going to need to train the models. So I didn't mean to neglect his contribution. It's very important. So thank you.
Yeah. And Jeff, that Southern Valley Center tunnel that had the encroachment by the surrounding rancher there, we've excluded that, and
nice.
Hopefully that's back to its original use. Megan.
There we go. Thank you for giving me a chance to talk. Hi.
Hi.
Nice to see this, Jeff. I just had a question. So, this AI stuff has been in development for a while. There's been a number of efforts to create this type of work. I'm wondering, for example, I know CDFW is working with Wildlife Insights on adopting some processing with their AI system. And we were going to run I think it's 7 years worth of pig data through this. And, I've got another 2 years of connectivity monitoring camera stuff that we were going to try and test with that program. I was just wondering if you're doing any sort of like cross-platform comparison of how well what you're doing might line up. Just for example, like I know the Wildlife Insights has, tens or hundreds of thousands of images of certain species that we have, which is a real benefit of having such a large user base, which might be more limiting if you're just working on something within the San Diego region. So I was just curious about those kind of the sample size and kind of comparison validation issue.
So I mean, these algorithms are really data hungry, especially as the problem becomes more complicated. So more data, the better. And I mean, I guess eventually it's going to be great to have some sort of image database that people could draw on to train these things, because the performance can be kind of problem specific. There's it's saying there's no free lunch. There's a whole paper about that, but you can train something to be generally good or specifically good on a particular problem. So there might be different versions of models that are trained for specific purposes, like something like identifying whether or not photos have pigs or not would be a pretty easy problem. Probably picking out photos say that have bobcats, or people might be targeting specific species. For example, they're trying to trap them, like when we did the eagle work, we want to know very quickly where the eagles are and aren't, so we can go out and put traps, that kind of thing. But once you start broadening out the number of taxonomic groups you're trying to identify, it becomes a much more complicated problem with much greater data needs. So I think in the future, it'd probably be pretty great to have some sort of open source library of images that people can use to train these things for whatever kind of problem they're working on. And those images would have to be sort of indexed so people could pull out what they need and use them. So I don't know if that answered your question directly, but
Yeah, sort of. I would mention that we've manually ID'd all of these photos for all large vertebrate species. So, you know.
yeah, so that's like a great training set. I mean, if you you know, interested in contributing data to this effort, that would be great. And you know, and likewise, I mean, I have no problem sharing you know, any of the code, especially once it's working well. And we get it, you know, we have to get it reviewed internally, but it's, you know, there for people to use once we have it working well. So
Any other comments or questions from the group? I don't see any hands raised. Anything in the chat? I don't see anything.
No.
Well, Jeff, thanks so much for this. It was great information, and you know, keep up the good work on this. It's pretty exciting.
thank you.
Okay, well, we have come to the end of our meeting. The next working group meeting is scheduled for Tuesday, December 14th at 1 p.m. as usual. And we will still, as far as I know, be in a virtual platform, correct?
Yeah, I think
Joy.
until the end of the year.
Okay, one of these days we'll see more than just, you know.
We get great turnout too. So
we do actually. We get really good turnout in virtual meetings. Anyhow, I do miss seeing you all though. So thank you all for coming. Thank you all for participating. Everybody be safe out there, and we'll see you in a couple months. Meeting adjourned at 2:50. Thank you, Kim.
Thank you, everyone.
Thank you.
Bye.
Bye.
Thank you.
All right.